All right, so we are going to look at what a reference angle is. We're going to use reference angles a ton in this class. You'll see them a lot on the ACT. A reference angle is, so if I have an angle in standard position, it has to be in standard position. So here's my angle in standard position. The reference angle is the angle distance right here to the nearest x-axis. The angle to the nearest x-axis. We've already kind of done some work on these. These were confusing some of you in the last chapter with the billiards thing because they had a theta here. But if you look at that, if I had these two angles and I put them into the calculator, I would get the same answer. It's just going to be sines. Okay, so a reference angle has to be, here are the two things that have to be true. Number one, it has to be acute. And number two, it has to be positive. These are the two things that are true. If you look it up on, like if you Google it, it will give you formulas, but I just draw them. It's way easier for my eyeballs to see it than use a formula. Because like 315 would be to right here. Well, the nearest x-axis is 360, right? So my answer on this, my reference angle would be 45 degrees. Okay. I'm just going to make a bigger, if this is okay, I'm going to make a big one of these, and then we'll get rid of it at the end. Okay. So if I make a big axis here, so on my next one, 150, right? 150 would be in quadrant 2, so this is 150. The nearest x-axis is 180, so this answer would be 30 degrees. Okay, on the next one, if I did 20, my 20 would be right here. My nearest x-axis is 0, so this angle is 20 degrees. Okay, so the next one is at 239. So here would be 180, and so 239 would end up somewhere down in here. The nearest x-axis is 180. So you're going to do 239 minus 180, and your answer is 59 degrees. Okay, and then probably the hardest one to see because you're going to go more. So I'm going to go more than, there's 360. And then if I add 90, right here would be 450. So that means 425 had to happen somewhere in here. So the nearest x-axis is 360. So 425 minus 360 is 65. So this answer is 65 degrees, okay? All right, so to determine the reference angle, there's a couple ways of doing this. Way one is kids will take 1908 and they will subtract 360, they just keep subtracting 360, 1188, subtract 360, 828, subtract 360, subtract 360, and my answer is 108. So the first thing they do is figure out that it's 108. Well, then if I draw 108, that lands here. 108 is closest to 180, so then I'm going to do 180 minus 108, and my answer is 72 degrees. Okay, so they just subtract. The other thing is, because it's okay, but that's a lot of subtracting. So what some kids do is they take 1908 and they divide by 360 and they figure out how many times around it goes. So they divide by 360 and the answer is 5.3. So if I take 360 times 5, that's going to get me 1800. So then I can do 1908 minus 1800, and that gives me 108, which is the same process. Okay. All right. So if I use way two, I'm going to do that here. So I'm going to do a negative 1116 divided by 360. So that comes out as a negative 3.1. So it's going to be 3 full times around. So 3 times 360 is 1080. So if I do a negative 116 minus the 1080, I end up with 36. Okay. Or I could do the same process. I could start with this negative 1, 1, 1, 6. I could add 360, add 360, add 360 until I get to 36. Both ways would work. I would definitely let you have a calculator. All right. This is the part that's going to bother a lot of you. Find all of the angles. There's an infinite amount. So what I'm going to do, since tangent is negative, in quadrants 2, in quadrants 3. Okay, I'm going to get out my calculator. I did not mean 3. I meant 4. I drew it in 4, but I said 3. Okay, I'm going to get out my calculator so you guys can see this. So I'm going to do the inverse tangent, and I forgot that decimal already, 1.3764. So the inverse tangent, I have to go back, 3764 is 54 degrees. Okay, and it was negative, right? So negative 54 degrees. What that does is it gives me the reference angle. So I know that the reference angle is 54 degrees into quadrant 2, right? So I'm going to do 180 minus 54. I'm just doing this over here on the side. It's 126. So I know that one of my angles is 126 degrees. But then couldn't I do coterminal? I could add 360, add 360, add 360, subtract 360. So we're going to put a formula on it, and we're going to say plus or minus 360n. That just took care of the one in quadrant 2. So now I'm going to throw that 54 degrees into quadrant 4. So I'm going to do 360 minus 54. That's 306 plus or minus 360n. So those are my answers. Now, if you look at the next example, we already did it's 54. So if I have a positive tangent, I would be in 1 and 3. Well, we already know one of the answers, 54 plus or minus 360n, right? That takes care of the one in quadrant 1. So now I'm going to go 54 degrees into quadrant 3. So I'm going to do 180 plus 54, 234. So I get 234 degrees plus or minus 360n. Yes? Okay. So find all of the angles that satisfy the following. If we look at this, I'm going to do this one. If we look at this, signs are positive in 1 and 2. So I'm going to inverse sine. So I'm going to sine negative 1. Already forgot it. 0.2346. 0.2346 is 13.6, we'll say. So that's 13.6 degrees. That one is in quadrant 1. So my answer is 13.6 degrees plus or minus 360n. That takes care of the one in quadrant 1. But I also have one that's 13.6 degrees into quadrant 2. So I'm going to do 180 minus 13.6. And my other answer is 166.4 plus or minus 360n. Okay. So now I'm going to do the same thing on the next one. If my cosine is negative, that's in 2 and 3. Okay, so I'm going to inverse cosine. Cosine negative 1, negative 0.1823 is 100.5. Okay, so that gives me this one in quadrant 2 already, 100.5 plus or minus 360n, right? But I need to find the reference angle. Okay, so what is 180 minus 100.5 is 79.5. So I have to go 79.5 that way. So 180 plus 79.5 is 259.5 plus or minus 360n. Okay, you have to put the n on there. If you forget it, I will take off because it's telling me it's a pattern. All right, so then on the next part, through what angles has theta turned if it terminates at 1, 4? So through what angle has it turned and what is its reference angle? So if I draw this, I have a point at over 1 up 4. So I have this. Okay, there's this point right here, over 1 up 4, 1, 4. So can I find this angle? Wouldn't I do the tangent of the angle is opposite over adjacent? So I'm going to pick up my calculator and I'm going to do the inverse tangent of 4. And I get 75.96 degrees. Okay, is that how far it turned? Yep, because it was in quadrant 1. Is that the reference angle? Yes. So this actually answers both questions because it's in quadrant 1. But on the next one, it is not so because you have a point at -4, -3.5. Okay, so I'm going to find that theta by doing the tangent of theta equals -3.5 over -4. So the inverse tangent of a -3.5 divided by a -4 is 41.19 degrees. Okay, look at this angle. This angle is not 41.98 degrees. That is the angle it's turned from standard position. So, excuse me, Lordy. It's not the angle. That is your reference angle. Good morning. That's what happens when I try to make too many of these in one day. So I found the reference angle. The reference angle is 41.19 degrees. The turning angle is looking from 0 all the way around. So I'm going to do 180 plus that. And I get the turning angle is 221.19 degrees. Okay, so those are the two answers. All right, the last thing you're going to have to do is be able to do these without a calculator. Please, please, please understand, this is no calculator. This is the no calculator part of the test. So if I have an angle of 315 degrees, right, then I could draw a triangle, any triangle on this line. And what's going to be true since this angle is 45? Can't I pick like 1, 1, and this is the square root of 2? Okay, but that's wrong. One of those coordinates is wrong. Wouldn't this be going down 1 since I'm in quadrant 4? So wouldn't the sine of 315 be a -1 over the square root of 2 times by, so wouldn't that be a -√2 over 2? Wouldn't the cosine of 315 be the same thing except it's positive? And then wouldn't the tangent of 315 be a negative over a positive, so a -1? Now you can check them with your calculator, but it will be on the no calculator part of the test. Okay, so on the next one, I have 150 degrees, right? So that means if this line is 150, that means that this angle is 30 degrees. And if I make a triangle here, then I could make my short leg 1, which would make my hypotenuse 2, and would make this the square root of 3. But it is going back, so wouldn't this be a negative? So wouldn't my sine of 150 be 1/2? And wouldn't the cosine of 150 be a -√3 over 2? And wouldn't the tangent of 150 be a 1 over a -√3, which would be a -√3 over 3? Okay. All right. So let's take a look at the next one. If I do the same thing with a -210, so I start here and I'm going to go, here is 180 and here is 210. My reference angle is 30 degrees, right? So can't I put a triangle on this? This should look really familiar. Isn't this the same? Look at these two triangles. Aren't they the same? Okay, so I'm trying to show you the sine of 150 is going to be the same as the sine of a -210. They are coterminal. So I don't have to. That's why this seems like it's going to be hard, but there's only so many of them you can have memorized. These are going to be the same answers that I already found. Okay, same thing. Take a look at 510. So here's 360. Here's 450. Here's 540. So 510 would be 30 away. This angle in here would be 30 degrees. Well, wasn't that the same as this one and the same as this one? So my answers are going to be the sine of 510 or 1/2. The cosine of 510 is a negative root 3 over 2. And the tangent of 510 is a negative root 3 over 3. Okay? All right, last ones. This is where you have to kind of think a little bit. These have to be on the no calculator, which means you should know them. Root 2 over 2, you start doing this enough. Root 2 over 2, that's a 45. Okay, so this is a 45, and my cosine is negative. So that must mean it's my 45 here, and it's my 45 here, because it's where those are negative. So what angles would that be? Wouldn't this one right here be 135 degrees plus or minus 360n, because it's saying all of the angles, okay? And then wouldn't this one be 45 on the other side? So wouldn't that be 225 plus or minus 360n, okay? All right, so the sine is 1/2. I do not have these memorized. Okay, so like if I make this a 60 and this a 30, and I make this 1, this 2, and this root 3, because that's the long leg. If I stand in the 60, my sine is root 3 over 2, right? If I stand in the 30, my sine is 1/2. So I don't memorize these. I know this is standing in the 30, so it's a 30-degree angle. So now I just need to find the quadrants. Sines are positive in 1 and 2. So that means one of my answers would be the one in quadrant 1, which is 30 plus or minus 360n. Okay, the other answer is going to be the 30 degrees in quadrant 2, which we've already done up above. So I would do 180 minus 30, so that's 150 plus or minus 360n. So these will have two answers, and you should be able to solve them.